In this section 2.4, we're going to be talking about dividing polynomials, also the remainder theorem and the factor theorem. We're going to start with long division to divide polynomials. Not every polynomial can be divided using what's called synthetic division, so you do need to know how to do long division. Most of the things that we're going to be doing will allow us to use synthetic division, which is easier and faster, but not everything. There are some things that require long division. We're going to talk about the remainder theorem and the factor theorem. Okay, so long division, what do we have to do? We have to write it in descending order. So the highest power, both the dividend and the divisor have to be written in descending order. So if you had something like 4 plus x, and that needs to go into 7 plus x squared, we would have to rearrange it. So we would have to switch these around. We would have to put this first and this second and this last. It does have to be written in descending order. This will make a lot more sense when I have an example in front of us, but we're going to divide the first term in the dividend by the first term in the divisor. Again, that will make more sense when I show you an example. Multiply, put it underneath, then you're going to subtract, except for I'm going to tell you to not subtract, but actually add the opposite, which is the definition of subtraction. Bring down and repeat. Okay, so let's see this work. Okay, what does this say? F of x and d of x are both polynomials. The degree of this one is less than or equal to the degree of this one. Then there exists unique polynomials here and here. Such that the remainder, this is the remainder, equals 0, or it is of degree less than the degree of this one. Yeah, whew. Okay. If the remainder equals 0, we say that it divides evenly and that they are factors. Okay. Yeah. Whew. Let's talk some math here. Let's do some examples, hopefully. There it is. Okay. So we want to divide this polynomial by this one. Okay. Well, this polynomial right here is not in descending order. It does have to be written in descending order. And they want us to use long division on this. So I'm going to put my 2x cubed first, minus 3x squared, minus 11x plus 7. Okay. Next, what I'm going to do is I'm going to divide the first term here by the first term there. Just those two. 2x cubed divided by x. My x will cancel, and I get 2x squared. Okay? I'm going to line it up with my x squared, so 2x squared. I'm going to multiply my 2x squared times this entire thing. 2x squared times x minus 3. And I'm going to put it underneath, should be a 2. Like that. Okay. With long division, what we usually do is subtract. We're just working with numbers, we subtract. However, that being said, you need to remember to subtract all of it. Well, that's easier said than done when it comes to subtraction, and people always mess it up. So what I tell my students to do, instead of trying to remember to subtract, which messes people up, I recommend that you distribute the negative and then add. Okay, so I would make this one negative, and then I would distribute the negative here, make that one positive, and then add. So I have a positive 2x cubed and a negative 2x cubed. Those will cancel out, which is my goal. If that didn't happen, then I messed up somewhere. And I'm going to add my x's, and then I'm going to bring down my negative 11x. Okay, those steps that I just did, I'm going to repeat them over again. So I'm going to take my first term, 3x squared, and divide it by my first term x. My x's will cancel. I have 3x. I'm going to put that on top of my x. Then I'm going to multiply my 3x times my x minus 3. Distribute gives me 3x squared minus 9x. Distribute the negative, and then add. So my x squareds cancel out. I get negative 2x. Bring down the 7 and repeat those steps one more time. So my negative 2x, I'm going to divide it by x, gives me negative 2. I put it up there, and then multiply my negative 2 times my x minus 3. If this sounds familiar, this is the exact same steps that we sorry, I'm distributing the negative. The exact same steps that we use for actual long division with numbers. So this number right here, this number is called the remainder. Way back in the day, 3rd, 4th grade, whatever, you would put an R and then a 1. Well, we stopped doing that when we started introducing variables. So instead of R1 to indicate a remainder of 1, we are going to make it a fraction. So we've got 1, and then we divide it by x minus 3. So this right here, final answer, 2x squared plus 3x minus 2 plus 1 over x minus 3. So all of that could be done with a process called synthetic division. All right, what is synthetic division? Well, these are the steps, and again, this will make a lot more sense when I show you with an example. And I'm just going to keep going through because, yeah, this is just, there we go. Okay. So first thing we want to do is we're dividing by x plus 2, but with synthetic division, what we want instead of the factor x plus 2, what we want is the 0. X equals negative 2. This is what I'm going to use, okay? So I'm going to take a negative 2 and I'm going to put it just to the left and above, kind of like this giant half rectangle. And then what I'm going to do, I'm going to write the coefficients and the coefficients only of this, keeping in mind that it has to be of the form. So if this is an x cubed here, so my degree is 3, so then I have to have ax cubed. I have to have some number times x squared. I have to have a number times x, and I have to have a constant. Okay, so in this case, I have a 1 times my x cubed. I have a 0 times an x squared, right? Because that's just 0. And I have a negative 7 times x and my constant. So the numbers that I'm going to use are 1, 0, negative 7, and negative 6. I'm going to write them next to, but on the other side of my line. So 1, 0, negative 7, negative 6. The first number, we don't do anything other than just drop it down. From here on out, we're going to repeat, not dropping the number down, but we're going to repeat what I'm going to talk about next. So we're going to take the 1 and the negative 2 and multiply those two together. So 1 times negative 2 gives me negative 2. And then I'm going to write it here. And then I'm going to add these numbers together. And I'm going to erase all that extra stuff because it's looking kind of messy. I'm going to erase this, and that one, and that one. Okay, that cleaned it up. And actually this one as well. There we go. So we add the 0 and the negative 2 gives me negative 2. And now we're going to repeat that process. We're going to multiply this negative 2 by this negative 2 gives me 4, and I'm going to write it underneath here. And then I'm going to add, gives me negative 3. And then I'm going to multiply to give me 6. And then I'm going to add and get 0. Okay. So after the first one, we multiply, add, multiply, add, multiply, add until we run out of numbers. Okay. Now, how do we read our answer? Read your answer from right to left. Don't try and read it from left to right. I get more students messing it up if they go left to right. Okay, starting from the right, this is your remainder. This is your constant. This is your x to the first power. X squared, if I had something over here, then I would have an x cubed. I would just keep on going if I had more and more numbers. But I don't have those numbers, so I don't have those. Okay, so I would have 1x squared, negative 2x minus 3, and my remainder is 0. So I don't need it. Most students, when they see synthetic division, think that that is much easier than long division. I would agree with that, but you can only use synthetic division in certain circumstances. Okay, what are the circumstances? Okay, you can only have a 1 times an x plus a constant. You cannot have 2x plus 7. Can't do it. You can't have an x squared plus 3. Doesn't work. So anytime you have a power of x, you cannot use synthetic division. Anytime you have a coefficient other than 1, you cannot use synthetic division. It has to literally be x to the first power plus 2, plus a constant, in this case plus 2. So it's very limited, although we use it quite a bit. Okay. I think we already did that, didn't we? It's not the same example we just got done doing? Okay, the remainder theorem. The remainder theorem says that if I take a polynomial and divide it by x minus a constant, then the remainder is equal to f of that constant. How would we use this? Let's suppose I have a function f of x is equal to, I don't know, 15x to the 5th plus 9x to the 4th plus x squared plus 7, whatever, right? And I want to find f of 2017 for whatever reason. Instead of taking 2017 and plugging it in for x and plugging it in for x and plugging it in for x, what I can do instead is divide 15x to the 5th, 9x to the 4th, 3x squared plus 7 by x minus 2017, hint, use synthetic division, and the remainder will be the same thing. That's not supposed to be a 0. I was just indicating that whatever you got. So whatever you got for this right here would match your remainder. That's what the remainder theorem says. I'll give you a hint. That was much more useful before calculators were invented. Okay, so we have f of x is equal to 3x cubed plus 4x squared minus 5x plus 3. They want us to find f of negative 4. They do not want us to take negative 4 and plug it in for x. What they want us to do instead is use the remainder theorem. So, plus 4x squared minus 5x plus 3, if we were to divide that by x minus a negative 4, we would end up with the remainder. Or the remainder of what of this division would give us f of negative 4. Okay. So we're going to have negative 4 on the outside. 3, we don't have any missing terms, so I don't need to add any zeros. So this is to the third power. I do have a number for my x squared, I do have a coefficient for my x, and I do have a constant, so I don't need to worry about any missing terms, and they are already written in descending order. So I'm going to drop the 3, and then multiply, and then add, and then multiply, and then add, is that 27? I did double check on my calculator, that's 27, and then we multiply, and then we add, so f of negative 4 equals negative 105 because my remainder is negative 105. Okay, what about the factor theorem? The factor theorem says that if we plug in a constant and end up with 0, then x minus that constant is a factor, and vice versa. So if x minus a constant is a factor, then f of that constant equals 0. Okay, let's see what we mean with an example. We need to solve the equation 15x cubed plus 14x squared minus 3x minus 2 equals 0. Given that negative 1 is a 0 of f of x equals 15x cubed plus 14x squared minus 3x minus 2. Well, how does that help us? So we know that f of negative 1 equals 0, because that's what they just told us. And because f of negative 1 equals 0, then we know that x minus a negative 1 is going to be a factor. So x plus 1 would be a factor of this right there. And what we're going to do is use that fact, that x plus 1 is a factor, to factor this down to a point where we can factor a quadratic. Because we have tools for factoring quadratics. What we don't have is tools to factor a cubic. So let's see what we can get. So I'm going to take my negative 1, 15, 14, negative 3, negative 2. I'm going to drop my 15 and multiply, and then add, and then multiply, and then add and multiply, and then add, and I did indeed have a remainder of 0. So right now, in factored form, I have x plus 1 because of this. And then I have 15x squared minus x minus 2. This is quadratic, so we can use quadratic tools to factor that. So, because it has 3 terms and this is a 15, I'm going to use the AC method. So I'm going to multiply, actually, you know what, I think we're going to see if I have extra room on the next slide so I have more room to work. Okay, there we go. So I'm going to multiply the 15 times the negative 2 and get negative 30. This is the AC method. And I'm looking for numbers that will multiply to get negative 30, but we have to add to get negative 1. So I'm seeing 5 and 6, negative 6. So 15x squared plus my 5x minus my 6x minus 2. We're going to factor by grouping. We have 3x plus 1. I forgot my minus 2. 3x plus 1. And 3x plus 1 because we have a GCF. And then 5x minus 2. My little 2, it's hard to see in there. Okay, but I already had an x plus 1. Right? From the prior slide, I had an x plus 1 and I had a 15x squared minus x minus 2. Well, I just factored my 15x squared minus x minus 2 into this, the 3x plus 1, 5x minus 2. Once I have it in factored form, then I can set each one equal to 0. And I get negative 1, negative 1/3, and it looks like 2/5. Okay. And learning reflection.